integral is an integral that has limits on it like this from 0 to 7. You guys really haven't seen any yet that don't, because we don't know how to deal with those yet, but we'll learn it Monday. So here we have a graph. It shows velocity. If it shows the velocity of a car in feet per second traveling along a straight highway. And we are supposed to find the integral from 0 to 7 and describe its meaning. Okay, so integral from 0 to 7 of v of t dt is the area underneath the curve from 0 to 7 here. So we're looking at that area underneath the curve right there. What shape have we got? That is a trapezoid. I'm going to probably type this faster than I can try to write it here. So that area, for a trapezoid formula, you got 1/2 times the height. What's the height of that? 2. And then base 1 plus base 2. The bottom base of that is 7. The top is 2. So that is just going to give us 9 for that. So that will be our integral from 0 to 7 of v of t dt. For here we'll get 9. What does that mean in terms of a car traveling along a straight highway? Okay, 9 feet in, over what time period? 7 seconds. So from t equals 0 seconds to t equals 7 seconds, the car travels 9 feet. I guess somebody is pushing it. It's only gone 9 feet in 7 seconds. Not very far. There. Not like us in Germany, no. Okay. Questions on that? All right, let's keep going. Now, this should not be 18. It should be 10 right here. And I didn't change it because I can't write good with the mouse, and I didn't want to make it even worse. But that should be a 10 instead of 18 right there on both of these. So whenever I'm looking for actually, several things, it should be 7 to 10. Change that to make that 7 to 10 right there. So this on the bottom should be a 7, and this should be a 10. And then this one right here should be 0 to 10. So 0. Okay, so when we're looking from 7 to 10, we will be looking at this area right here between the curve and the x-axis. And what shape do we have there? Another trapezoid. So we got 1/2. And what's the height of that one? 4. And then the bases are 3 and 1. And so we get 8 for the area, but what is the answer for the integral? It would be -8. So that integral from 7 to 10 of v of t dt would equal -8. What in the world does that mean if it's -8? It's negative because it's under. It's still sort of the distance the car traveled, but you can't have negative distance. What does the negative part of that tell you? It's going the opposite direction there. So whatever direction was probably forwards and backwards in this particular case. So in this case, I'm out of room. I'm going to put it over here. The car traveled, or first of all, we should say time period, from t equals 7 to t equals 10 seconds. The car traveled backwards 8 feet. And that is that's describing example 2. Right there. Okay. Questions on that part? So from 0 to 10, what am I going to do to find that? Combine those two pieces, right? So I'm going to have 9 plus my negative 8 right there. And that is going to be equal to 1 foot. What does that mean? Okay. Joshua, who has had physics, used the word displacement. What does it mean, displacement? How far away you are from where you started. And we talked about this some whenever we've done some of these like position, velocity, acceleration before. It is like if you need to go to the bathroom, you walk all the way down here, it's closed, you got to walk all the way back to this one. Your displacement for my room is not as far as the total distance that you traveled. So when you integrate velocity, it is going to give you the displacement. So this would tell you that at t equals 10 seconds, the car is 1 foot in front of or where it started at t equals 0 seconds. Since it's positive, it's going to be in front of where it started. If it was negative, then we'd get that it's behind where it started. It does not tell us the total distance. What's the total distance that that car traveled? 17 feet. Because if you're looking at total distance, you wouldn't consider the fact that that 8 is negative, because it's still moving that far. Okay, questions there? So, let's make us a table here. We did this a little bit the other day. And hopefully, let me type in here. Okay, so if the car is located at the point x equals 0, at t equals 0, so you are starting at 0, then find the values of the position of x, or x of t at that point. So if we start at 0, we're at 0, right? Okay, then if I go down here for 1, if I look right here at 1, where would I end up? It's not 1/2, because we're finding the area of that triangle. And that triangle has a height of 1/2, so it's going to be 1/4 there. So we're finding that little tiny area. Where would we be at 2? That's going to be a triangle with a height of 1 and a base of 2, because we want to, it probably is 3/4 from 1 to 2. But all of these are going, we're thinking of like 0 to that number. So it would be just 1 for that. Okay, so for 3, it looks like we're going to add a whole block right here. It might be helpful to, let me kind of highlight what we're, yeah, I think 2 1/4. I'm going to have to switch to, let's make that wider so it's not going to work. Okay. The next one, let's see, that would be 3. I think it's going to be 4. Yes, I think that looks right. Because that would be like 3/4, and that would be 1 that you'd be adding to it. What about at 5? That'd be 6. What about at 6? 8. And 7. That would be 9. Okay? Now, what's going to happen when we get to 8? Now we got negative area. So I got all this up here was my positive 9, but I got a negative 1 right here for this area. So that takes me back down to 8. And then at 9, looks like I'm at, so that's 1, 2, it's like 3 more, so that takes us down to 5. And I just couldn't put 10 on this table because it only lets me put 10 lines on the table in this program. So let's add 10. At 10, where would we be? 1. Okay, so this would give us at least the points. We don't know the numbers in between this, but the points that we would have for our position function. And notice that if you look at the pieces that we looked at, like at 7, you get 9. That's how far we got from the integral from 0 to 9. And then here we get 1 for that. Okay, questions there? Okay, so let's think about this right here. The integral from v of t from 0 to 10 dt. Right. I wish I had made this start somewhere besides 0. That would make this problem better. My integral from 0 to 10 of v of t dt would be 1. Correct? But could I also say it's 1 minus 0? Would that be okay? So I could say that it was this right here minus this right here. That would work. Let's think about like the integral. Let's do one that we didn't do. Let's do the integral. Let's do an easy one right here. What's the integral from 4? Integral from 4 to 6 of v of t. That would be 4. Now, if I look right here, could I do at 6 I get 8, at 4 I have 4. Could I do 8 minus 4? Would that give me the same answer?
Yes.
It would. And we could keep going with this, and it's going to be the case for everything. Because if you think about, this is the displacement from 4 to 6. So I subtract where it was at, position at 6, minus the position at 4. And that's going to give me how far the car was displaced there. So this is another application of the fundamental theorem of calculus. So we've already done fundamental theorem of calculus where our derivative, when we take the derivative of the integral, and it basically just like cancels each other out and we get the function itself, right? That is one version of the fundamental theorem of calculus. Another version of the fundamental theorem of calculus is that if f is continuous on the interval from a to b, and f is an antiderivative of f, what that means right there is that another way that that could be written is that capital F prime just equals lowercase f. A lot of times to show they have integrated, like if you're integrating the function g, they will call it capital G for that. So So if I'm trying to integrate from a to b f of x dx, it is going to equal capital F of b minus capital F of a. This is how it would look like in a velocity acceleration sort of situation. When I integrate, so like, let me write this down. Like we got x of t is position. If we take the derivative of that, we get velocity. Right? And if we take the derivative of velocity, we get acceleration. We've been working with that quite a bit. We've seen it several times. Whenever we integrate, we're going backwards. It's the opposite of differentiation. So if I integrate velocity, it'll take me back up to position in this case. So if I have the integral of velocity from 1 to 4, then sometimes we write this intermediate step. When you integrate velocity, you get the position formula. So we'll put x of t, and then we'll put this bracket over here where we put our 1 to 4. This is sort of an intermediate step right here. You don't necessarily have to write it. And then this would be x of 4 minus x of 1. It is always top minus bottom for that. So to think about it, if you're integrating velocity, you're thinking about the displacement from 1 to 4, which would be position at 4 minus position at 1 for that. Okay. If we do the same thing, but we start with acceleration, what do we get when we integrate acceleration? We're going to get velocity. It takes us back up one step. So this one would be v of 3 minus v of 0. So if I want to know the accumulated change in that acceleration, I would take my velocity at 3 minus my velocity at 0 for that. I skipped that intermediate step here for that one. Okay, questions? All right, so let's look at some of the types of problems that you might have. This is a calculator active problem. If you got your computer up, you can pull up Desmos. If you don't, just follow along here because we've only got 10 minutes left. So we know f of 3 equals 2.345. They give us the equation for f prime. I'm going to, because of the way Desmos works, it will not do stuff if I call this f prime. So I'm going to call it, I don't like that it won't let you type in f prime. I'm going to call it, I'm going to call it d of x for derivative, but it is f prime. I don't like calling it f because f is what we get when we integrate this, so that's a little bit confusing. So I'm going to call it d of x for derivative, and that's natural log of x squared plus 1, which is this function here. And they give us f of 3, and they want us to find f of 5. Okay? So the way that we would set up this problem is, I don't know f at all, nor can I find the value of f. But if I integrate f prime of x, what will I get when I integrate f prime? I'll just get f of x, right? So I know f of 3. I'm trying to find f of 5. So it would be possible for me to integrate this from 3 to 5. If I integrate from 3 to 5, when I integrate f prime, I will get f of x, and then I would have to evaluate that from 3 to 5. And that's sort of that intermediate step. You don't necessarily have to write that down. So that means the integral from 3 to 5 of f prime of x dx, sorry, this is so ugly, is going to equal f of 5 minus f of 3. Gosh, that's bad. Now, here is the facts. We know f of 3. It is 2.345. 2.345. We do not know f of 5. That's what it's asking us for, so we don't want to replace that. Because that is what the question is asking us for in the first place. This is what we're trying to find, so that does not need to be replaced. We definitely do not, at this point, know how to find the integral from 3 to 5 of f prime of x dx. Here is the good news. Desmos does know how to do that and can do it for us, and this is calculator active. So if you go over here to functions and go down towards the bottom, right there under calculus, there is an integral symbol. And you're going to type in 3 to 5, and you're going to do d of x. It is f prime, but Desmos does not let me type in f prime, so d is my f prime. And then you have to put a dx on the end, or it won't take the integral for you. And you get this number right here. And right now we have absolutely no idea how Desmos is coming up with that number, but apparently that's the area under the curve from 3 to 5 right here, and it can figure it out. So this is going to be 5.631. Here, that's the value of all of this stuff right here. So if I want to know f of 5, what do I need to do? I've just got to add 2.345. And I'm going to add that to both sides. So if I take that number, 5.631 plus 2.345, I'm getting 7.976, which is answer choice D for that one. Okay, questions? All right, we got 5 minutes. Let me do this table problem for us. They've given us a table. It gives us selected values here. And I've got the integral from 0 to 3 of f prime of x dx. If I integrate f prime, what do I get? I get f. So I will have f of x, which is evaluated from 0 to 3. This is sort of an intermediate step. At this point, it's not all that important that you write it. It will become a little more important when we get to actually doing it algebraically. So then I would have f of 3 minus f of 0. Where do I find f of 3 and f of 0? Table. I'm looking at that middle line right there. So f of 3 would be 10. F of 0 would be 4. And so I would get 6 as the answer. Right there. And let's see. Okay. This last one is very similar to the one we already did. They give you G of 4, and they're asking you to find G of 1. It's a calculator active problem, so I'm not going to go through the whole thing, but because you've got G of 4 and G of 1, I would set up the integral from 1 to 4 of G prime of x dx. And when you integrate G prime, you will get G. So this will equal G of 4 minus G of 1 right here. And so Then you would just plug in the numbers that you know. You got this right here. You'll do this other part on the calculator, which I don't think I have time for because it's about time to go. But you'll do this on the calculator. You'll get some number here, and you just solve it for G of 1 like you did the other problems. So our textbook does not have a ton of questions that are like this. It goes straight to being able to do it algebraically. So I have just given you 3 problems at the end of these notes. That is your assignment for this section. Okay. So if you'll have